these tools can't answer all possible questions about the climate data, but the kinds of questions that they can best answer about a location are, what's the climate of a location? How does the weather vary from year to year? Or how different was the weather this year than it is from normal? Um, so for example, with climate, we know that climate is different than weather. Weather is what you get, climate is what you expect. And we normally assess climate as a long-term average of weather, like a 13-year average, where the average is considered normal. How the weather varies each year. We know that each year brings some variability in temperature and precipitation. Some years are wetter and drier than normal, others are hotter and colder than normal, and normal is what we expect on average, or the climate. And then how this weather this year is differing than normal is the last question that we can understand. So for example, I'm going to go through a list of a couple tools here. Let's see. I'm going to check my time real quick. Yep, so the historical tool and the historical Climograph tool is one of the tools that can answer the question about what's the climate of a location. This tool produces a climograph for a location where it shows the monthly distribution of precipitation and temperature. And precipitation are the gray bars, so here we've got almost 1.5 inches for December for Burns, Oregon. And the red is the average maximum daily temperature for that month. And the blue is the average minimum temperature. And so these three metrics, the temperature and precipitation, really are the first basis for assessing the climate of an area and how they differ, how the climate differs for different locations. Yep. And so the second tool we can use to answer these questions is the climate tracker tool. And this tool answers how does the weather vary each year. The tool produces a bar chart of monthly seasonal variables for each year between 1979 here and 2021 here. You guys can choose from some different variables. We saw a list of the variables that were supplied in this tool earlier, and you can also refine those by looking at March, a different season. So you can define your season for spring to maybe be March through May minimum temperature. So you can look at how the temperatures have been varying for springs over the last 40 or so years. Yep. And there's another tool we have that looks at that same information. And actually in the climate tracker tool, you can also look at a scatter plot and you can put a best fit regression line on it. So you can look at some information about what the trend is. So here you've got a regression in six days per decade in the last spring freeze date to earlier dates. And we have some information here on the correlation and the statistical significance of a regression test. There's another tool called the climate scatter, which pretty much has the same information as that last historical trends tool, tracker tool. But here you can set two variables, one for the y-axis and one for the x-axis, and you can see a scatter plot over all the years of what May minimum daily temperatures look like with respect to last spring freeze dates for Medford, Oregon. And again, you can select the variables to put on the different axes from a long list of variables. And you can highlight certain year ranges, like the most recent years, to see where they fit in the scatter. Another tool, the third tool that we can use to answer this question is the climate dashboard tool, and this answers the question of how different was the weather this year than normal. There are other tools that can answer this as well, but this is a dashboard view of those answers. And so the user here can set they can set the variables to go in each of these four panels. Here I've set average minimum temperature in the last 7 days, average maximum temperature in the last 30, total precipitation in the last 7 days, and total in the last 30 days. And we get some information on exactly what those values are. What the departure from normal is, which means like here that the average minimum temperature is 2.6 degrees Fahrenheit above normal, or the precipitation here is 2.4 inches below normal. And also a qualitative description here, just showing here that for Portland, Oregon, they've had the record lowest precipitation for the last 30 days. Another historical tool that we have is the seasonal progression tool. It's used to monitor current weather as well, where you can see how we got to where we are today. So here's to this is the progression over the year. And so here's today in May 2021. And this is the progression over the water year starting from October 1st. And you can see this is the cumulative precipitation. So if you add up the precipitation over the water year and see how it has evolved, then that's the red line is that current precipitation for this year. The black line is the average from the last roughly 30 years or 40 years. And then we get some shading here to represent the percentiles from those year ranges. So we can see not only if we're above normal or below normal, but how above normal or below normal we are with respect to what we have seen in the past. Yeah. Another tool that we can look at that has all the same information, but it's available here on summary maps, is the Climate Mapper tool, which is our most versatile mapping tool, where you can zoom in on locations, you can alter the colors, and you can even do some simple masking. It's a real GIS tool. And shown here is a map of the mean daily vapor pressure deficit from the last 7 days over Oregon. And it's shown as an anomaly of current conditions compared to the mean from 1981 to 2010. And this metric can help you to understand fire danger as it's a measure of atmospheric dryness. So we have lots of different kinds of metrics all over in the tools that can help you to look at lots of different things. And on the subject of dryness, another tool called the US Water Watcher gives a view of current drought conditions through many different drought metrics. So here we have up in the right corner, we have the drought classification from the US Drought Monitor. And I picked a location here. It's the same location on all 5 of these maps. The drought monitor says that that location is currently in moderate drought. And then I can choose from these different panels what to show in the maps for these 4 2x2 maps here. And so what this tool allows you to do is to look at different drought types. So for precipitation, I can look at precipitation for that location, which is a measure of meteorological drought. I can look at stream flow, and which is a measure of hydrologic drought. Vapor pressure deficit is probably an ecological drought metric. A Palmer Drought Severity Index is a measure of soil moisture, which can be tied to agricultural drought. And so at this location, we see that we have different answers for if they are in drought or not. And really the reason why that is because drought is any deficit of water, and that, but the demand for the water distinguishes the different types of drought. And so we can see a map of overall of Oregon here in these different drought types. We can also see a little summary classification in the lower right here for the location that we picked, what the different droughts are, the drought classifications in the different types, and then also the US Drought Monitors type. So that's just a quick little way to look at these tools.